All right, so now let's think about regions that may be a bit less what we call them, less friendly to rectangular coordinates and more friendly to polar coordinates. So how would you integrate? And this is an example I did in class, so it's not very different. So I will, that's 1 and 2, let's say. That doesn't look like a 3, it looks like a 1 and a 2. So let's say you have 2 circles, concentric circles, if you believe those are circles, but they're circles. So let's say you have 2 circles, concentric circles, and you want to integrate over this region. And then you realize that this region is not very nice when you think about it in terms of the rectangular coordinates, because this equation here will be x squared plus y squared equals to 4, and the one inside is going to be x squared plus y squared equals to 1. If you notice that motion, is because I teach on my tablet all the time, and I was going to hit the undo to so that is what I was doing. All right, so you have that region. So if you want to integrate over this region, then you have to break it into a lot of them, a lot of different regions. So for example, you could partition it if you're going to start integrating first in the x direction, so you get functions of, in the y direction first, sorry, to get functions of x. So you would have to partition from here in a vertical line. This will give you one region that you would be going from the negative square root. I'm going to solve this equation for y. So you'd have the negative square root of 4 minus x squared. And then you would integrate 2, and when you solve this one, you get the positive square root of 4 minus x squared for the y. So your y would be going from negative 4 minus x squared to positive 4 minus x squared. Then in this little region, you would be going from the positive square root of 1 minus x squared to the positive square root of 4 minus x squared. In this other region, you'd be going from the negative square root of 4 minus x squared to the negative square root of 1 minus x squared. Did I already convince you that this is not very suitable for rectangular coordinates? It would give you 1, 2, 3, 4, 5, 6 integrals. Not very nice. However, if you write that region in polar coordinates, the radius is going to be from 1 to 2. I started in the wrong position. Let me write it down below here, and then I erase. The radius would be between 1 and 2, and the angle would just be between 0 and 2 pi. And so your integral, if you were to integrate there, your area for that annulus would simply be the integral between 1 and 2 and 0 to 2 pi of the differential of area in polar coordinates. But what is the differential of area in polar coordinates? I'm going to write it. It'll be r dr d theta. Why? Why r dr d theta? It turns out that if you partition this, now you have to partition it into different segments of angles. And then you have to partition it in terms of different partitions of the radius. And each one of your differential of area would be one of these things over here. And it takes a little bit of, not a lot of work, it's just a difference of squares. But turns out that the area of that will be just r delta theta. And as you take your limit as delta r and delta theta goes to 0, you end up getting r dr d theta. I'm not going to do the calculation. It's not really that difficult, but I already did it in class, so we're not going to waste time on that. So now let's take a look at what happens though, or how do you transform from one system, say rectangular coordinates, to polar and vice versa. So let's go ahead and set one integral up. Let's say that you want to compute the area of this region. And so what we're going to do is firstly we're going to draw it. So remember the graph of the cosine quickly. When the angle is 0, cosine is 1. When cosine is, or angle is pi over 2, the cosine is 0, so you're already here. Between it, I should have said when the angle is pi over 4, which is one that we need, your radius is going to be the square root of 2 over 2. So when it's pi over 4, you get square root of 2 over 2. And if you remember the graph of this function, it's a circle. But now, the region you're looking at is where the angle goes from 0 to pi over 4. So you want the region or the area of this little slice there. Now, I wouldn't say it's pizza because then you're taking a big chunk and you're leaving a little bit for somebody, but you know, you do you. So the way you would calculate that, as we said, is going to be the area of r dr d theta, and the radius is going from 0 to cosine, and then the angle is going from 0 to pi over 4. Now our goal will be to write this in terms of rectangular coordinates. So how can we do that? So we have to write the equation of that circle firstly. So you can write r equals cosine theta, and you multiply both sides times r, you get r squared is equal to r cosine theta. And then you get that r squared is x squared plus y squared is equal to x. That is the equation that determines this circle. So this circle in rectangular coordinates now is going to be of the form x squared plus y squared equals x. Perfect. All right. Now we need to figure out this line here. Now this line, you don't really have to do much because the line is just the line y equals x. Why is that? Because you know that y over x, and I'm writing all over the place with this example for some reason, but I'll keep going. So y over x is going to be the arctangent of pi over 4. And so this is 1. Arctangent of pi over 4 is 1 and gives you y over x equals 1 or y equals x. So that gives you that line there. Because you have that sector is just this sector theta equals pi over 4. And so whenever you do arctangent of pi over 4, you get 1, and that gives you the equation of the line, y equals x. So I need to integrate this region. So what is the easiest way to do it? I believe is going to be by doing a horizontal rectangle first. So I'm going to go from left to right. So when I'm going to go from left to right, my area is going to be, so I'm going from left to right. So this has to be a function of, x has to be a function of y. So I'm going to integrate with respect to y at the end. And so I have to do dx at the beginning. Why is that? Because whenever I write this, whenever I'm going to go in a horizontal fashion, I'm going to get that this point is going to be something x equals a function of y. And this other x coordinate is going to be x as a function, let's say f of y. So when I do that, and I put those as my first endpoints, I need to integrate with respect to y lastly, so I can get this to become a number. That's how you want to think about it. And so the function I get here is the equation of the line, which is x equals y for this one right here. So the bottom one is easy, it's just y. Now for this one, I have to solve for x. So how do I solve for x? And my space management is fantastic today, so I'm gonna have to work here and write my answer there. Not ideal, but I gotta solve for x on this one equation here. So I'm gonna have x squared minus x plus y squared equals 0. I'm going to subtract y squared on both sides, and I'm going to have x squared minus x plus something is going to be equal to negative y squared plus something. And what is that something going to be? What am I aiming to do? Is I'm trying to do a completion of the square. So I'm going to grab this negative 1, I'm going to divide by 2, and then I'm going to square it. So 1/2 squared is going to be 1/4 here and 1/4 there. The equation is still an equation is still equal. I haven't changed anything just yet. And this is going to be x minus 1/2 squared is going to be equal to, let's put the 1/4 first. So we have 1/4 minus y squared. Now I can take a square root, and I get x minus 1/2 is going to be plus minus the square root of 1/4 minus y squared. And at this point, x is going to be, I'm going to add 1/2 on both sides. 1/2 plus minus the square root of 1/4 minus y squared. And that is going to give me my two possibilities for the x value. However, notice that the plus side of that solution is going to be this, and the minus side is going to be this one right here. I don't care about the minus one, I care about the plus one. So we're going to write it as 1/2 plus the square root of 1/4 minus y squared. And if you think that this integral is nicer, well, you do you. Now I have to look at my endpoints for x. So I'm going to be going from 0 to this endpoint here, which is 1. So the bottom, the x's are going to be going from 0 all the way to 1. And that gives me my endpoints for the x. So that's how you would transform this beautiful and easy integral to compute to that. And you pick. However, in the exam, I'm not going to ask you to solve the integral. I'm going to ask you to convert from one to the other, just so I know that you can manipulate the integrals and actually rewrite the regions in both coordinates. So that's how you would deal with those. And then after that, once you have it in one or the other form, you can just proceed to integrate. But that's not the idea for the video. You guys know how to integrate already. So I'm going to leave it at that. And so thank you for watching, and I'll see you in the next one.